Okay, so I'm doing question number 19 from Unit 6B. This is Section 5.7 corrections. Okay, and so we're looking for the number of positive real zeros, negative real zeros, and imaginary zeros. And we're going to use Descartes' rule of signs, and we're going to make a table summarizing all the possibilities. So the key is we've got to look for sign changes. Every sign change means we have a positive zero. Okay, or a possible number of those real zeros. And remember, they tend to come in pairs. So let's check to see what we got. We got a sign change, yes. We've got another sign change, yes. That is not a sign change. This is a sign change, and this is a sign change. So it looks like we have 4 sign changes. And then we'll count backwards by 2. So we have 4. So we could have, so our options are 4 positive real zeros, 2 positive real zeros, or 0 positive real zeros. We got 3 things that could happen. Okay, we're not sure which one's going to happen until we actually analyze it, but it gives us an idea. Okay, the second part is to find negative ones. Okay, so for negative ones, we have to, for negative zeros, we have to check f of negative x. That means we have to put a negative in here. So we're going to get, so I'm going to plop that in there. I'm going to pause it and plop them all in to save time. So when I put negative x in there, so it's negative x I'm putting in, negative x, negative x, negative x, negative x, negative x. It turns out the only time the negative stays is when the power is odd. Then you're going to have a sign change in the powers. So this is a 1 here, so it's also going to change here. So I can actually then go look at the sign and end up change this to positive, change this to positive sign, change this to a negative sign here. So I'm going to rewrite it here. Again, I'm going to pause it to save time, and I'm going to have it rewritten with all the sign changes. Okay, so I'm back, and that's what that simplifies to. Okay, so remember, negative x has 5 negatives to it. When you're looking at this one right here, it had 5 negative signs on it, so every pair cancel out. So I was left with 1 hanging out there that changed the sign. Same thing here. I had an odd number of negative signs on those x's, so when I multiply, one of them doesn't have a pair to cancel out, so it's going to cause the sign changes on those individual terms. So now what we need to do is figure out the actual sign changes to find our negative zeros. Okay, so this is a positive to a positive, that's not a sign change. To another positive, that's not a sign change. Oh, to a negative, there's a sign change. Okay, now it's negative to negative, that's not a sign change, and that's not a sign change. So it turns out we have 1 sign change, and then we're going to count backwards by 2. And so we really only have 1 negative 0. Okay, 1 negative 0. But you don't have negative 1 negative zeros. So now we can make our table. I'm going to do that on the next page. Okay, so on our table we're going to have a total. We're going to have positive sign changes, positive real zeros, negative real zeros, and imaginary zeros. And those, remember, come in pairs. They have to come in pairs. Okay? So we said the total power, if we go back, the total power was 5. So everything's going to always have to total to 5 when it comes to zeros. So the first thing is we have a total of 5. And we could have 4 sign changes. I mean 4 positive zeros. Or we could have 2. Or we could have 0. Okay? Well, if I have 4 sign changes and I have 1 negative, so not 4 sign changes, 4 positive zeros and 1 negative 0, that's real, I have no more zeros left because I've already totaled 5. Okay? If this has to total 5, and I have to have 1 negative 0, negative real 0, because it has to cross the x-axis once, then I'm left with 2 to equal 5. And if I have 5 sign changes, 5 zeros in total, and none of them are positive, I have to have one negative 0. Well, that means the rest of them have to be imaginary. Now, I have no other choices. I've used all the 3 options for positive real zeros, and I've used the only option for negative real zeros. That's all I've got. I don't need to do anything else. I don't use 0 because I've got to remember you have to count backwards by an even number, and 1 minus 2 would give you a negative 1. So I can't have negative 1 negative real zeros. Okay? So that's my table there, and that's the end of it.